In this video, I wanted to talk about electromechanical relays and how they can work with Jekyll-Labs control boards. The concepts are applicable to almost all prop controllers, but I'll be talking specifically about the Jekyll-Labs boards. Most of these boards use MOSFETs to control the power flowing to the prop. They turn off and on super fast and can control a moderate amount of power. There may be scenarios, however, that a relay would be a better choice for controlling your prop. For example, if you needed to simultaneously operate a bunch of wiper motors, or had one wiper motor, but it was under really heavy load, a relay could be a good choice. Or maybe you needed to control something that's powered by household electrical current, like this big blower motor, or the trigger for a fog machine. Also, a relay is a great choice for controlling almost any store-bought animatronic with a try me button or pad. But not everything needs a relay. You can power a lot of really bright lights just using the standard MOSFETs on the controllers. Most wiper motor props don't need a relay unless there's going to be significant load or the risk for jamming. And smaller DC motors work great with just a MOSFET. If you have any concerns about your DC motor, best option is to get a multimeter, hook it up in series, and measure the actual amps drawn by your prop. Anything less than a sustained current of 5 amps should be just fine. When I reach for a relay, it's likely to be one of these Bosch-style automotive relays. They're rated for 12 to 14 volts, have 5 pins, and are sealed against the elements. Most of them also come with these wiring harnesses, which makes it very easy to integrate with your prop. They also give these really satisfying clicks whenever the electromagnet causes the relay to change state. Now let's talk about how these work. Inside the sealed box, there's basically two sides of the circuit. One side, along with a resistor, is this electromagnet, and when current passes through it, the magnet turns on, sucks by any nearby metal thing. The other side is a switch. When the magnet turns on, it causes this switch lever to alternate back and forth between the two different outputs. And notice how there's no electrical connection between the two sides of the circuit. This bottom connection is frequently referred to as common, and the output that's normally where the switch is open is called normally open, and the output where it's normally connected to common is called normally closed. And the magnet, when it turns on, will shift the switch over to the normally open. So typically, normally open is not connected to common, but when the magnet's on, boom, normally open is connected to common. And Bosch-style automotive relays typically give numbers as well as labels to each of these. You can look at the diagram on the top to sort of see. So 86 and 85 run the electromagnet, 30 is the common, 87 is the normally open, and 87A is the normally closed. You can see these when you look at the bottom of the panel. So for the first example, I wanted to show you what it looks like when you use a relay to connect a twitch board to a try me button, something where the power supply is completely separate from the power supply to your twitch board. So for this example, you're going to have your 12-volt power source here on the left, the twitch board in the middle with the power supply as well as the output for the twitch board. On this side, you're going to have your relay. And then down here, you're going to have your prop. Let's say it's sort of a little like scary skull that says something. And there's lines coming out that take you to a try me button, but we're going to cut those off. So cut the button away. And then we're going to use those wires to connect into our relay. And so first off, let's go ahead and run power from our 12-volt power supply over to the twitch board. And then directly out, remember we need to connect 86 and 85 to run our relay coil. And those are going to be connected to the output of the twitch board. Electromagnets don't really care which direction the current goes, and so you can hook up positive and negative to either 86 or 85. And then on this side, we want the common to be one side of your try me button. and 87 to be the other side of the try me button. This way, whenever the twitch board sends a signal to the relay, the electromagnet will create a connection across the try me button and activate your prop. If your prop also runs on 12 volts, but you're worried it's going to draw too much current that would make your MOSFET heat up, then the relay can be a nice option for that. So in that case, you're going to have your 12-volt power supply, the twitch board, along with its input power and the output power from the twitch board. Then you're going to have your relay, and then your motor. We'll just, any sort of random big heavy motor that's sort of running your prop. So power is running from your power supply, positive and negative over to the twitch board. And then, remember, 86 and 85 are the electromagnet for the relay. And so that's what we're going to connect to the output for our twitch board. So the twitch will just be turning the relay off and on and off and on. And then 30 is common, and we're going to attach 30 to the positive terminal. And then 87 is our normally open. So normally it's off with not a connection. But then when the twitch board is twitching, it will cause the magnet to click on and then supply power via 30 and 87 to your motor and turning on. And so that's how that works. And now we have that same circuit in real life. You can see that you have the power supply going to the twitch board, the output from the twitch board going to 85 and 86 for the relay. The 12-volt power supply also connects to pin 30 on the relay, and then 87 continues that positive power to the motor. Motor ground connects back to the common ground of the whole circuit. And now you have a system where the heavy current is carried by the relay and the twitch board shuts it on and off.